Lesson 2, properties of radical functions, and we're going to do quadratics now. Okay, so just like with lines, we're going to graph the original parabola, and then we're going to square root our answers. So if I plug a -3 into this equation, so we're going to plug all these in, we'll make the table of values. -3 squared is 9, plus 1 is 10. -2 squared is 4, plus 1 is 5. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1, and then we're going to repeat ourselves. So we're going to graph this. Let's go every 2 lines is worth. 1 on the x-axis, and then we're going to go up by 1s on the y-axis. So we have -3 and 10, which is right here, -2 and 5, -1 and 2, 0 and 1, 1 and 2, 2 and 5, and 3 and 10. Oops. Right here. Okay, so here's our parabola. Okay, so it looks like that. The domain of this parabola is x such that x is an element of the real numbers. The range is y such that y, and we want it to be greater than our vertex, so greater than or equal to 1. Alright, let's square root this. So if I do this and I square root my answer from the previous one, I square root 10 to get 3.162. Square root of 5 is 2.236. Square root of 2 is 1.414. Square root of 1 is 1. This is an invariant point. And then we start repeating ourselves. Remember that whenever y is 1, it is going to be an invariant point. So the way that this works is our 1 stays the same. So we plot 1 here. Oh my gosh. 1 here. And then when I go over 1 space, it's going to go to 1.4. So it's going to get smaller on both sides. But before it gets to that point, it is going to get a little bit bigger. It's going to go above the line. Okay, go over 2 places, and it should be 2.2. So it's like somewhere like here on both sides, and then 3 on the next one. So like this. So the way that it's going to look is it's going to come above, and then it's going to go up like that. So domain is the same thing. It's still x as an element of the real numbers. Range for this particular graph doesn't change because our invariant point was the vertex, so y is greater than or equal to 1 for all the real numbers. Okay, next example. We're going to sketch the square root of f of x and state the domain and range. So first let's do domain and range for the original function. So this one, x is an element of the real numbers. It goes left and right forever. The range is going to be greater than that vertex, which is at 4, -4. And it's greater than because we're going up. On this one, domain is also going to be element of the real numbers. It generally is for parabolas like this. And our range is going to be y is less than or equal to 9. Because that is our maximum point, local maximum. Okay, to graph the square root of the functions, you're going to start by plotting your invariant points. So our invariant points are the x-intercepts. You can't really see that. The x-intercepts, and where y equals 1. So right there, right there. Then you're going to go somewhere where there's an easy square root. So right here is where 4 is, so we're going to bring it down to 2. Same with on this side. And then you just sketch. So there is our radical function. So the domain, so this one, the domain is going to be different because it's going to be to the right and to the left of these points. So we're going to say x can be less than or equal to 1, and that would be for this side. Or x could be greater than 5 for all the real numbers. And our range is, it just needs to be greater than 0. Okay, next one. We're going to plot our invariant points, so our x-intercepts, where our y equals 1. I missed that completely. And then we're going to go up to this vertex, and we're going to square root the vertex so that we have a better maximum point. So it is 9, so it's easy. It's going to go to 3, and our function is now like this. And we don't put any arrows because we can't go any lower. So for our domain, we want to say that it's in between -3 and +3. So we'd say -3 is less than or equal to x, which is less than or equal to 3. And our range, this one has boundaries. So we want to say it's between 0 and 3. So we'd say y such that 0 is less than or equal to y, which is less than or equal to 3. And there's our domain and range for those functions. So talking about different types of graphs and possible radical functions, we're going to just sketch what they would look like. So we could have a graph that has 2 x-intercepts and it's opening up. We could also have a graph that has 2 x-intercepts and it's opening down. We could have a graph that has 1 x-intercept and it opens up, or 1 x-intercept and it opens down. We can also have a graph that opens up and doesn't touch the line, or opens down and doesn't touch the line. So those are our 6 options of how a quadratic could look. Our rational functions then are going to look like this. So if it's this type of graph, it'll look like that. If it's this type of graph, it'll look like that. We just did those two. This type of graph will look kind of like that. So it'll go up. This type of graph is really easy. It's literally just 1 point, and it's the x-intercept. If it's completely above the line, it's going to just kind of get wider like this. And if it's completely below the line, there's absolutely no drawing. So thinking about that, that'll affect your domain and range. So there's not one set way to do it with, like there was in lines. There's quite a few options here. So that's quadratics. And now we're going to go on to cubics.